My name is Michael Farrell. I'm a Civil 3D industry expert and mostly assigned here at ATG on the support team. So I've probably helped you if you've had any Civil 3D or map support issues. What we're going to look at today is eliminating gaps in your surfaces. And we've all seen this. And the odd part is that sometimes it's us, and sometimes it's the data, and sometimes it's the algorithm inside Civil 3D. And I'll show you where that's coming from in a moment. And you can kind of control it. Sometimes it helps and sometimes it doesn't. So I won't bore you to death with a whole bunch of PowerPoint. We're going to move on to the next slide. So what we're going to try to cover today is how to identify and correct some gaps. And I'm going to try to show you a couple of alternate strategies for bringing surface data into Civil. One of those will be using Infraworks to process your terrain data and then exporting that back into Civil. And if you don't have it open now, if you want to kind of follow along with some data, you can go ahead and open your Civil 3D and Infraworks right now. And also, I put my email address up here because if you have a surface that has some gaps in it that you'd like me to look at during the class, you could let me know, maybe in a chat, say, hey, I've sent you something, and I can bounce out of here and go download it, and we can have a look at your data. If that is something you're interested in, then we can do that. The reason that we want to try to get rid of these holes, they basically create a situation where if you're trying to get earthwork volumes, you're going to get incorrect volumes because if your proposed surface overlaps those holes and you do a volume surface, Civil 3D actually tries to fill that hole. So the reason we want to solve that problem are incorrect earthwork volumes, and it can cause some errors in the way the contours display. I know that's probably an obvious statement. If there's a hole, you're probably not going to see contours. So, and then you'll see that the holes are easy enough to spot. There's a couple of good ways to see them when they're happening. One, have your surface boundaries turned on. I know sometimes we don't always do that. We have our surface style set to not show the boundary. And so you wouldn't see the hole as clearly if the boundary was turned on. But another method is that if your surface style has their triangles turned on and you set your view to shaded, then you'll see some holes as well. So I'm going to jump out of here. And so here's some surface data. And you'll see with the boundaries turned on in the surface style, the hole is pretty obvious. Okay. So if I turn that boundary off, these guys are extra. I'll hide them. So you just might not see the hole. You know, you see triangles, you see contours, you just might not see the hole. But if your view is shaded, you'll see the hole quite clearly. Okay? So, and again, where does that hole come from? Well, sometimes when we build a surface, you guys have seen these operations when you're adding data to a surface where it talks about minimizing flat faces, simplifying it. So some of these values on this definition tab, this swapping edges, some of these settings can introduce those holes. And so you could try you know, turning those guys on. And when you do the rebuild, that itself may introduce some holes itself, but it looks like it didn't, although it did cause some interesting things over here. Okay, so those pieces behind the scenes, this stuff, can impact whether you see holes or not. And these may or may not be set all to yes in your default template. I don't know. You'll want to check that. Okay. So that's kind of the source of the holes. The solution is fairly simple. You have a couple of options. One, you could grab the surface and use the add line command and just connect that. But you'll see it doesn't fix the whole hole. So you'd have to stitch that back together like a spider weaving a web. Okay? And as you can tell, that would be like the least desirable method. Okay? Because, you know, as you can see, that just take a whole bunch of time, especially if you had a bunch of holes. The better option is to just change your surface style. And this drawing isn't really set up the way I like it to. Typically under properties, I'd like to be able to choose a new style. Over here, I like to have an editing surface. And in there, I can turn on my points, my triangles, and contours, and make sure that in the model view, I might also want to see my borders, maybe even my points. Okay? And that way I can just pick that editing style and then he assumes the right data. And let me shrink this stuff down here. Okay. So now you can clearly see the holes. The easiest and fastest way to deal with those guys, grab your surface, come up here to the launch pad, and we're going to extract some objects. We want these borders. We want that guy and his friend over here. And we want this guy here. And then you'll see when I'm done, I now have 3 objects. And those guys will happily jump into my surface over here. Those are boundaries. I know they don't look like boundaries because they're on the inside. But you'll see I can have an outer boundary. Typically you're limited to 1, but you can have multiple show boundaries. If these were curved, I changed my accuracy on my mid-ordinate data, but they're not. We simply say OK. And you'll see the holes have been patched. Now, the last thing I want to do, and I don't know about you, is to leave a bunch of these guys laying around in my file. Okay? So to clean them up, there's an interesting setting under your surface properties. Right here under the build definition, quote, copy deleted dependent objects. How many of you guys use that tool? Little show of hands, no hands? Anybody? No? Anyway, what this guy does, and I use it quite often, especially if I've added contour data and or optional break lines to a surface that don't come from survey figures. I don't want to keep those objects in my file. So if I change this to yes, what that allows me to do is grab those borders and just delete them. Now, ordinarily, that would cause the surface to get excited. And I'll show you that. Okay. Make sure they both came back. Okay. See, if I change that to no, and then I grab this guy and his friend, and I delete it, you'll see the surface gets excited. If I actually rebuild it, I get holes again. Okay? So that's where that command setting, I don't even guess it's a command setting, but that's where setting this guy to yes can let you get rid of some of the underlying AutoCAD objects that you use when you're building a surface or editing a surface. And then the surface basically makes a copy of that data that it saves internally. So even if you delete it, it's still there for you. Okay? Now, similar to this function, this isn't really a hole, but this is a case where the design data introduces a bunch of these really long triangles. And as you can tell, it also creates problems with the contours. And this is a finished ground surface, so this is dependent upon when this break line was added to the surface, what choices were made in terms of the supplemental or weeding factors on this break line. And that contributes to these big long triangles. If you don't want those big long triangles, and they don't create a hole as much as they just create these weird spots in the contours. That's no fun to, so you can even see that little break around there. So those things are no fun to clean up. But what you can do is you can either use a feature line or a 3D polyline. And I'm just going to drop that in here from the midpoint of that triangle to this endpoint. So this line is basically, perpendicular across these contours, and it's at the proper surface elevation. And then we'll go ahead and add a point. We'll use the midpoint And you'll see, and then we'll use that endpoint. And so that gets rid of that big flat surface that popped up in there. And you can, you can manipulate that. You could decide, well, I really should have went from here to that point and from here to that point, and then maybe even include this third option. And what that does, you can see it got rid of that break point that was happening across those contours in the previous view. See how that break that really doesn't exist is now gone? And see how all the little squigglies in those contour lines on this side are gone? And we'd probably want to do something like that over here to get rid of these sawtooths. Okay, questions on that? Okay. Now over in this other file.
Yeah, one quick question.
Okay.
So if I was to have already smoothed the surface, then it would, I would already have smaller triangles in this area. So I should do this before smoothing?
You could test that out. There's a real good way to use the surface properties button to your advantage. If you have that file open, and you probably don't, what you can see is if I grab a hold of this surface and go to his properties, one of the most, I believe, underutilized tools inside Civil is this definition tab. Okay? How many of you on a normal basis go and visit this definition tab? Okay? So basically some of the same guys that were having holes in the surfaces, but some of you visit it. And what's really handy is your smooth operation would show up. Okay? So what you could do is turn it off. Like it never happened. See that? Even this show boundary. That guy can be removed. And then you can see the results if you hadn't done that. If you like it with it on, then you can always pop back in here and say, yeah, I want that, I want that, I want that. And or that smoothing operation that you did before, you might still want it, but you'd want it after. So you can actually move that operation to after the fact, after you've added those extra points to get rid of those long triangles. And then when you hit apply and rebuild, then your smoothing operation would still be there. You wouldn't have to recreate it. You basically saved it for later by turning it off and then doing whatever other operations you wanted to do to the surface, moving it up or down, then turning it back on, and then the surface regenerates itself with that same data and those same data operations, just in a different order.
That's a good tip. Thank you.
Okay, thanks, sir. So that's, just one of the things that can go on. Good question about, quote, proximity break lines. I'll answer that live. and I'll tell you, I have a very I'm looking for the right word because I don't want to make anybody mad. I have a very prescriptive way that I like to use break lines, okay? And I'll take a moment to talk about break lines and why, how, when, and where to use them, okay? And this is all my theory. And it comes from many years of using Land Desktop. My experience with Civil 3D goes back to the very beginning of Civil 3D. And before that, Land Desktop, all the way before it was even Land Desktop. So that's what I'm basing these opinions on, okay? So in your surface, and I'm not even sure which one I'm working at here, but in your surface, that's a data shortcut. When it talks about break lines, okay? They give you 1, 2, 3, 4, 5. In my world, I prefer that you only ever use standard and wall, okay? And the reason for that is the way that the proximity break line works, how it actually functions, is imagine that the surveyor had surveyed this ground, right? And we just had this style on there. And we asked the surveyor, hey, does this look right to you? And the guy goes, well, no. I remember there was a swale that kind of went through here. Okay. So you break out your trusty sketching skills. And he goes, yeah, that's about right. That's where that thing was. Okay. And I have 2, 4, 7 vertices on there. If I add that to that surface, as a proximity, notice all of my weeding and supplemental factors are disabled. Not sure if I like that. So that's one reason I don't like to use the proximity. And when I pick that guy, you'll see it added it to the surface, but it didn't really make a swale. See, this contour starts to point upstream, and then it doesn't. Anybody want to tell me why? Anybody? Bueller? Yoda? Anybody want to tell me why?
Multiple elevations on the polyline?
Oh, close, but not exactly. So I'll give you exactly what's happening. Because the surveyor didn't actually survey that feature line, it doesn't have actual elevations on it. You saw me draw it at 0. I just drew a polyline. And what the proximity break line does is it finds the elevation. Oh, now there's a tricky one. See the survey point here? See the survey point here? They're almost the same distance away. It grabs the elevation which is proximal to the vertex. Now, was that the real elevation of that swale? Or are we just guessing? okay? So that's one reason I absolutely do not like to use proximity brake lines. Because in theory, if that was a feature that should have been surveyed, then I believe it should have been surveyed. And simply trying to fake a swale into a surface, probably not the best way to go about terrain modeling, right? Okay. So that's why I don't like those guys. Okay. The only brake lines I like to use, and this is a different version of the surface though, that's why I got some, my holes are back, because I messed with it. Anyway, but we can, you know, fix them just like we did before. So I don't like proximal brake lines. In my world, I only like to see standard brake lines and wall faults. And I positively never want to see a, quote, non-destructive brake line. Because essentially you're adding a brake line to a surface that doesn't do what it's supposed to in terms of making sure all the vertices and edges of the triangle line up with the brake line. So in my world, standard faults and wall faults. Okay? Anybody know of a good time to use a wall fault?
We try to use it with back slope, and if there's a sheet pole, like a bulkhead in a way, actually. We do dredge pads where there's a dredge, you cut a hole and it back slopes up to a wall. I'm not sure if that's where you would use it, but that's what we're trying to do.
That's one way to use it. It also makes excellent head walls. I'll pretend that I know what I'm doing. Let's say this is some head wall structure. And it's just terrible CAD, so don't give me a review. Okay. Just winging that in there for you. So let's say you had a head wall structure like that. And I'm going to go ahead and set his elevation using the tooltip there at 4368.5. Okay. So that's the top of head wall. That's what the surveyor gave me. Okay. But if I needed to add that, need to add that head wall in there. Well, he is a wall. And typically, when I'm doing linear features like this, if I want to shorten up my triangles, I'll enter a normal staking distance, like 25 or 50 feet. And that'll get me more triangles along those edges. Okay. The key point with the wall fault, when you pick him, he's going to ask you for, quote, the offset side. So make sure you point away from the wall. Otherwise, I'd be making a hole inside there. So point away. And then it's going to ask me a crazy question. So I want to enter heights for all or individual. I'll go ahead and do them individually so you can see what that looks like. It works really well for things like handicap ramps and truck loading docks. If it's just a straight wall, it's a constant height or depth, you can use all, but I'll do individual. And see then right here, it's asking me what is the elevation or offset for that point. I'm just going to use delta and pretend I know what I'm doing. Okay, so the elevation difference right there, I'm going to say that head wall is 1.5 tall, so I'm going to go down 1 from the top of wall elevation. And same here. And then I'll let this come up at minus 0.75, and the same, and minus 1, and minus 1. And then here we'll get tricky. And back to minus 1. So what that did for me is let me build that head wall. Okay. And I prefer to do those types of features this way, above and beyond using feature lines and stepped offsets. Because you'll see that made my, made that wall. And it really pops up and does what it's supposed to do. If I was doing that same structure with a feature line, I'd have to draw that and set all those elevations and then do a stepped offset and then edit those elevations. And now I have 2 objects in my file that I have to keep track of. Whereas by using the wall fault, I have 1 object to deal with. So the wall fault can reduce the amount of objects that you have to keep track of and admin inside of your file, okay? And those are basically the only 2 break lines that I like to use. If you have a larger break line that has a lot of vertices, that's where you use the from file. And that guy has to have your X, Y's, and Z's on all your vertices. Okay. And what that allows you to do is basically build that break line without actually having the AutoCAD object inside of Civil. Spot elevations. Well, it depends. If literally the surveyor shot, quote, the top and bottom of wall information, then while I was going through the prompts, let me slide this over a little bit. Then when I was going through the prompts, and it was actually asking me for whether I wanted to use, right here, this very first question, inner option for wall heights, specify elevation or delta difference. So if they actually shot elevations, then I would use the shot elevations. If they simply did measure downs, if they shot this corner, this corner, this corner, and this corner, and then gave me an offset and measure downs, then I'd have to use that information from their sketch. Okay? Now, optionally, back to this surface with holes, sometimes those just come about naturally because you bring in the points, and if you recall, there's an option when you add points to the surface, whether you're going to minimize flat spaces, whether you're going to swap edges, there's those 3 options at the bottom. And those options can introduce those holes. Let me see if anybody sent me anything. Nope. Okay. Anyway, so those options can introduce those holes, as I alluded to. But what you'll see in drawing 5, well, drawing 6, is a different way to process your surface data. I used a little GIS application, and you guys may have Esri or some other GIS application in your office. And mine allows me to bring in a text delimited file as points. And then I can export it out as a shapefile. And you might say, well, Michael, why do we want to do that? Well, it helps solve this whole problem, okay? Because the way that Civil processes data, when you use a database file, it doesn't ask you those questions about minimizing or not minimizing. It just uses a different process. So in this file, what I do is just come up here and grab the Surfaces tool. And you may or may not be using this operation right now. It says create your surface from GIS data. Oddly enough, you only get to pick surface. Okay. But you can name it, you can describe it, you can put a style on it. All of that stuff that you normally see when you use the quote create surface dialog box. We're going to connect to a database. And it remembers where I went last, so no magic there, okay? And again, because it thinks you're connecting to a database, you have to log in. If you're actually connecting to a database, you'll have to have that information from your site administrator, okay? So we're grabbing a surface out of there. It remembers whatever coordinate system that it was exported at. You can change that on the way in if you want to. Okay. I say next. And a little bit of personal input. I think this box is funny because it wants you to pick where your data is at, and we don't always know where the data is at. And they didn't give you a button down here that says, give me everything. This is the button that says, give me everything. By picking nothing, you get everything, okay? We say next. And then you have to know what is in your data. I know that field 4 in my database file is my elevation. Okay. And then you have the ability to save this out as a processing template. So if you're processing this type of data frequently, you could save this out, and then you don't have to go through these steps. When I hit finish, I then have a surface. He pops right in. So that's where that comes in handy. And you don't have to worry about holes being generated because one, I'm not introducing them by saying, you know, minimize flat edges, swap edges. You know, I'm not toggling any of those operations that can and do sometimes introduce holes to the surface. And instead I'm using a slightly different methodology that so far I haven't seen the database method introduce holes just yet. Okay. So that's a little bit different operation. And like I said, you guys may have to have your internal, you know, your GIS guys process that file for you and turn it into a shape file. You just basically just use the normal, you know, CSV or TXT file and pull that in and then do an export as shape. And everything works out just fine. Okay. And then lastly, I'll pop in another file here. Lastly, I've recently been having some pretty good success with large LiDAR surfaces and Infraworks. Okay. This happens to be one that I got from somebody else. And what works really well, and I don't think I could open this guy because I updated. So that's some LiDAR data. Pretty sizable surface. Okay. And what I've discovered is that we'll take the whole baby out there. And we'll just push that right on out. Okay. And what I've discovered with Infraworks is because it uses a different engine. I mean, you guys have played around in there a little bit, I'm guessing. It just uses a different engine for processing the data as well as the visual display. And that works to our advantage over here in Civil, because we have our direct link to Infraworks. Then I can grab that guy in. And I've got some bigger data here. And what you'll notice, or what I've noticed, and some other users have noticed, is once you bring in this surface inside Civil, out of Infraworks, the display performance is a lot better than if you had brought that data in doing the normal processes, importing the points, bringing in break lines, and building the surface inside Civil 3D. You just wind up with a higher order of fidelity between the original surface and what comes into Civil. And I'll show you that with I think I've got a pretty good chunk here. Okay, so you'll see this is a pretty sizable chunk of data. I'll just do a little distance here just so you can get a rough idea of how big this thing is. So that's 8,000 feet, plus or minus. Pretty good chunk of data. But you'll see that your ability to manipulate it is a lot different compared to a similarly sized surface built with points and break lines and survey figures. It's just been my experience so far that Infraworks processes the data differently. You wind up with a lot better fidelity to your terrain. And then when you export it into Civil, the performance is just greatly improved. And I recently did this with a user, and he came back and he reported that essentially the resulting file size going through Infraworks versus how he had built it was about 1/3 the size of previous, with basically the same data. So it just, it processes it differently. Okay.
So can I ask you a question? I was curious about that because that's a problem that we're having at the moment. I think we have Infraworks. We haven't used it yet. But did you have to, when you imported it into Infraworks, is that all it was converting it to a IMX? You didn't have to get rid of any data from it
None
at all? It was just
None at all. Just bam.
Wow.
Yep.
Wow, we're gonna try that for sure.
And it also serves an interesting purpose, as you noticed that when I was exporting out, another thing that this guy does is if you find yourself with a large surface that it makes sense to maybe chop this up using data clips, you know, to put part of the surface in one file and another part in another file, then deref them together later. This guy gives you a nice option here. I can take any portion of this surface out that I want. So I can say in this export, just give me from here to here. And then when I've finished that, then it's just going to give me that data within the bounding box.
Right. Okay.
So that also, you know, you can see where that saves you literally even then on the, you know, once you bring it into Civil 3D, it's kind of like, oh, I didn't want that much. So now let me put a boundary on it. But you could essentially do that post-processing right inside Infraworks as you take the data out to Civil.
You can't create contours in Infraworks, right?
Sure, there's contours in here.
And export them out to a drawing or like a Navis model?
Navis will consume either the 3D model. You'll see he's going to take that guy out as a FBX. Oh, here. So Navis will consume either the 3D model, which takes it out as an FBX, and then you can pull it in that way. I'm not sure that Navis will consume the IMX file. So the two typical exports out is either IMX or FBX. This is the FBX format. And then the native format about what's going on behind here and kind of what sort of gives me the idea to use the database file is that Navis, I mean not Navis, but Infraworks stores the data in a SQLite database format. So it actually, you know, it's storing this similarly to how I got this from a shapefile. So a little bit different process. And like I said, my just over the last few weeks, I've had some users with some fairly large surfaces. One guy had a big coal mining operation someplace and was really struggling with file size and performance. And so we played around with a few things like exporting it as a DBF, exporting it as a shapefile, and then pulling it into Navisworks. Infraworks. Now you got me confused. Pulling it into Infraworks and then exporting it and pulling it into Civil as the IMX file. All worked out just fine. But the pass that we did where we took the data into Infraworks and exported that IMX file and put it into Civil, and the guy was almost giddy because the fidelity to the surface was there, the performance inside Civil 3D was there, his drawing wasn't laggy, he could see the level of detail in the terrain that he needed to make the design decisions he needed to make for like locations of haul roads and where to put drainage pipes and things like that. So it's just overall a better end result by taking the terrain data into Infraworks first and then pushing it out for Civil to consume. So if you're not currently using surface from GIS or your Infraworks models, this is kind of an opportunity to open that door for you.
We have used some GIS info also, but that info seems very large too. So you still think opening that up in Infraworks first or exporting it into Infraworks? I mean,
Yep.
well, I guess you got into using a GIS program also to shrink that file size down or data down, but
Yeah, it's just a shapefile. I have one that's fair. This same guy here. This same piece of data I have as a shapefile. And another thing that's nice about this button is pick one file. This button is grab all of the shape files in a folder. Mm, so here we converted, sometimes you'll get a file that's contour data. Here we did an export, a map export out of Civil 3D to make that shapefile. And he's quite chunky. Okay, so I'm not really hiding anything from you. He's a big file. We'll take it all. And this is one of those situations where, essentially somebody gave me a file that only had contour data in it. And so instead of adding all of those to the surface as either contours or break lines, for me, it made sense to just do a map export to shapefile.
I just recently had a project for this exact same issue. I got a drawing from a client, and it only had 3D contours in the file. So I wound up creating contours in my surface using those polylines, and this probably would have been a much more efficient way.
Twofold. One, once you actually process those contours to shapefile, you can get out of that file and save it so that you know that you never changed your original data. I've worked in civil long enough to know that as long as you can preserve the integrity of the original data, it makes answering questions later about why you did or didn't do certain things to a project. You can answer those questions a little bit more intelligently, and you can always fall back to that original data, in your received from others folder, and say this is where it came from, and know with confidence that it was never altered.
So I would use, let's say I just have a drawing that's contours only. I would use Civil 3D to make a shape file out of those contours first.
Map export. Yep.
Map export. Okay. Thank you.
Yep. And then once that's ran, you can then close the file and don't save it, because you have the shape file and all of the bits and pieces that go along with it. The projection file that knows which coordinate system it belongs in. You'll have all those pieces. So this is going to take a little while to process. But as you can tell, it's 1,100 bytes as a shape file. So it's imagine how big it was as contours. Pretty sizable chunk of data. So now to bore you once again with PowerPoint, that's some of the great things that you can do when you kind of move away from the traditional survey data format you know, just a CSV file or a TXT file, converting it into a shape file, and then processing it into either with Infraworks or pulling it into Civil 3D directly, you'll find there's some good performance boosts. Okay. So the end result of these processes, no more holes, a better surface model, no holes in that surface, and now you guys have some other ways to handle your data. So if you weren't thinking about those methods before, they're there. And he still looks like he's chugging away. So did anybody get Mr. Spiky Surface?
That would be Terry.
Yeah, I didn't send it in. I'm actually focusing on what you're showing because
Okay.
I'm getting better treatment that way.
Okay. Well, I'll just pop any random surface in here to 2019. Okay. Well, I used to have 2019. There we go. There's a. Okay. What works really well if you're trying to get rid of a spike, and I'll make one just to, so this is a fake surface that I have going on here. I'll put a spike in here on purpose, okay? And they're not always this neat, trust me, I understand that. But I'll put him up here at 15.5. And typically that's what a spike looks like. You'll see some random little hill or some random little hole. One of the easiest ways to get those guys into view, really, points on. Don't need the triangles. Okay. And if I flip this baby over, might even have to go a little bit more than that. The spike will appear. Right? And then you'd simply come in here and do edit surface and delete that point. If that point was even crazier, okay, you know, the surveyor meant to key in 4.5, but keyed in 450. Right? So those become a little bit more obvious. And then if you had a bunch of them, the easiest way is to come over here and just put this guy on his side, pick him, and then you just be able to go like this and grab any and all of them that were causing spikes, up or down, and then go back to your top view. Another option, and this is one of my favorites, but you got to be a little bit careful with it. We'll get back to this view. Okay. Another one of my favorites is to use the surface properties against itself. Okay. Min, max, mean. Well, that's just mean. Anyway, so you can use this number over here and go to the definition tab and say, you know what? let's not bring anybody in that's higher than 36 or 3 plus 6, you know. Did I forget to rebuild? I probably did. That button sometimes annoys me. That should have gotten that guy out of there. Let's try again. Build. That should have gotten rid of him. Wow, he really wants to stay. Typically, that would get rid of it. You could just say don't use points higher than or lower than what you know to be valid. And that guy should. See if he wants both of them here. Probably not, but because that should work. I know that's too high. Typically that works as well, where you can limit the range of data. And this might be just because I slammed that point in there manually. It's kind of, you know, not listening to me. Otherwise, normally it would get rid of them. So you can use that surface properties to set a known good elevation range to include or exclude data that shouldn't belong in your surface in the first place. Okay? And I know that we're about up on time, but I'll just share this with you as we go out. These are some fun corridor modeling examples that I was showing a guy. He wanted to know how to model his box culvert and head walls going underneath his roadway. Okay, so that's just an interesting corridor exercise. And I may do a session on those soon. So Infraworks is happy. Looks like this guy finally got happy. So there's all of that data from that shapefile. So here's that same chunk of data in Infraworks. And you'll see the way that it is able to handle it is just amazing compared to this one. And I'd probably get about, you know, a 50% improvement if I took that data out of Infraworks and pushed it into Civil. This guy, if it'll let me get there.
Quick question.
Because this one came out of Infraworks, but you see how much better that surface behaves?
Quick question, but it's on a different.
Okay.
How did you get? I made a shapefile. Where did you go to grab the shapefile and make the surface? Was it just create surface or create surface from DEM or?
Well, once you actually have the shapefile,
Yeah.
it's surface from GIS data.
Okay, found it. Thank you.
And the Only button on this box that I think is tricky, I shouldn't call it tricky, but it's this guy here that bugs me. Whoever the designers of this interface were, they don't make it clear on this page right here that selecting nothing gets you everything.
Yeah.
I personally would have preferred to see. I personally would have liked to see something like more like the map workspace, to where when you define your query, you get an option, all, some, or none. That would make more sense to me, to actually have an all button. But that's just me.
Whatever reason, when I did the map export, I made instead of a shape file, I made a Sdf file.
I'm not sure if this guy will use the SDF file or not. I typically
it doesn't say it will. Yep, I
Yeah.
have to figure out why I did that.
Oh, because you have to choose when you do your map export. You get a bunch of options. The default, if you've never used it before, is the spatial data format.
Okay, I got you.
Then XML, then E00, then Esri coverage file. Okay. And technically, you could push it out as the SQLite file, which Infraworks should load. I've never tried to load a SQLite with it, but it should work. So you just have to pick the proper format. And then probably the next thing that's tricky, not really, but it is that when this dialog box appears, this guy, when you pick stuff, and I'm just going to fake it here, okay? Notice I was on point. It said I found 157 objects, but it filtered them all out. That's my clue that those aren't point objects. So we switch to lines. Only 3 of them are lines. None of them are polygons. And none of them are text. So obviously I don't know my data well enough to do an export. So you want to keep your eye on this bottom line down here. If it's all getting filtered out, you've picked the wrong data type.
Yep, thank you.
All right. So anyway, that's our hour. Thanks you guys for sharing your lunch hour with me if you're on lunch. Thanks for sharing part of your daily production day with me if you're busy trying to get work done. I appreciate that. I look forward to hearing any questions you have, or if you have any samples of data that kind of pique your curiosity and say, hey, Michael, how you handle this? Feel free to drop me an email. And I love a good puzzle. So hopefully it's some interesting challenges that you're facing, and I can share some of my experience with you and help get you past those hurdles. Okay. So with that, I'll take us to our last little slide. I'd like to thank you for your time. I know you're busy trying to get things done, and hopefully these processes that we talked about can improve your end results, as well as the effort, the results of your efforts on your data. Okay, guys?
Thanks a lot.
Thank you, guys, and have a great day.